All right, let's talk about one of the most maddening errors you can get on a coding platform. You know the one I'm talking about. Time limit exceeded. TLE. We're going to demystify this thing once and for all. So picture this. You've wrestled with a problem for hours. You finally crack it, the logic is flawless, you hit that submit button, and bam, failure. But it doesn't say wrong answer. It says time limit exceeded. It feels like the system is just being unfair, right? Well, what if I told you the problem isn't that your code is wrong? It's just that it's too slow. So here's our game plan. We're going to figure out what this TLE thing really is, uncover the server's secret rule for how it counts time, connect that to the clues in the problem itself, see exactly why our code gets slow, and then, most importantly, find a way to fix it. Okay, first things first, let's get one thing straight. A TLE error is not an attack on your logic. It's really just a performance review. The server is basically saying, hey, great idea, but you need to find a faster way to do it. So, officially, time limit exceeded just means your code didn't finish running through all the test cases in the time it was given. You'll see this everywhere, from LeetCode to Geeks for Geeks. And the most important thing to remember is this. It's about performance, not correctness. Your answer could have been perfect, but you just took too long to get there. So that brings up a really important question. How in the world did these servers even measure time? Because if you understand this, you can beat the TLE every single time. You know, it's easy to imagine a server with a little digital stopwatch. It sees your code, hits start, and if you go over a second, it cuts you off, right? Well, no, not really. The way it actually works is way more interesting and, honestly, way more helpful for us. This is the number. 10 to the power of 8, 100 million. If you remember nothing else, remember this number. This is the secret key that unlocks the whole TLE puzzle. So, what does this number mean? It's a rule of thumb. When a problem says 1 second time limit, what it's really telling you is that you have a budget. You have a budget of about 100 million basic computer operations to get the job done. It's not about the clock on the wall, it's about how much work your code is making the server do. And what's an operation? Well, think of the simplest things a computer can do. A single if check, printing something, one single trip through a loop, or some basic math, like adding two numbers. Now, this is just a general guide. It can change a little bit depending on the server, but it's an incredibly powerful way to estimate. Okay, so this is where it all clicks into place. Every single coding problem actually gives you all of the information you need to avoid a TLE. You just have to know how to read the clues. And there are two main clues. First, you have the time limit. That tells you your total budget. 1 second, okay, that's a 10 to the power of 8 operation budget. The second clue is the constraints. This tells you the maximum possible size of the input, which we usually call n. You put these two pieces of information together, and you can literally predict if your code will pass or fail. So let's actually do this. Let's run through a quick example. We're going to calculate exactly why a certain approach would get a TLE, before we even write a single line of code. Okay, here's our mission. We need to sort a list. The problem says the time limit is 1 second, and the constraints say the list could have up to 100,000 elements. So our maximum n is 10 to the power of 5. So let's walk through the math. Our n is 10 to the 5th. Now let's say our first idea is to use a simple sorting algorithm that runs in O of n squared time, like using a couple of nested loops. To figure out the total operations, we just plug in our n. So 10 to the 5th squared, that's 10 to the 10th operations. Now let's see how that stacks up against our budget. 10 billion operations divided by our 100 million operations per second budget gives us 100 seconds. Yeah, that is way over our 1 second limit. That is a guaranteed TLE. So you see, the fix here isn't about making a few small tweaks to the code. The problem is the entire approach. We need a smarter, more efficient algorithm from the get-go. And just look at this comparison. It's night and day. The ON squared approach was going to take 10 billion operations, or about 100 seconds. But what if we used a more clever algorithm, something that runs in ON log n time? Well, for the same input, that's going to be way, way under our 100 million operation budget. The time taken? Less than a second. The result? A beautiful green accepted. This is what a TLE really is. It's the system's way of saying, hey, your logic is probably fine, but the way you're doing it is just too slow for the scale of this problem. You need to rethink your strategy. So let's boil it all down. 1.
TLE means slow, not wrong. 2, the magic number is 10 to the power of 8 operations per second. 3, always use the constraints to estimate how many operations your idea will take. And 4, choose an algorithm that fits within that budget. It's that simple.
Once you understand this rule, TLE stops being a frustrating roadblock and starts being a helpful clue. It's a signpost that points you towards a better, more elegant solution. So now that you know how to beat the clock, the only real question is,